in this case, what we're going to do is we're going to look at ionic and atomic radius. This one's the one that was covered before. This is my normal trend. So if we were comparing, we were going to go from Na, let's see, Na to Cl. So my atomic radius going from Na to Cl is going to be a decrease. Why is it a decrease? Because this one is a metal, it has less energy, so it's bigger. This one has more energy because it's a gainer. So big fat lazy loser. And then this one is a lean, active gainer. And that is for atomic radius. Now let's look at ionic radius. Ionic radius's trends do not seem to follow this one here. It is called something called Coulombic force or Coulombic force. Which in actuality is called a nuclear force. Nuclear force is like the attraction toward the nucleus. Again, it's a little bit harder concept to kind of picture, so you're going to have to listen to this maybe a few times. Now, I showed you the tendency for sulfur to get to argon is going to be a -2 charge. It means it's gaining electrons. If I were to draw it, and again, I'm not really worried about my neutrons, which are neutral. We're dealing with charges. So we're going to have 16 protons with sulfur. And then we got our things here. It's a little easier to show it with the smaller ones. So basically, there is my neutral atom. So this is an S neutral. What happens with an S -2? Well, here's what's going to happen with that. If I gain 2 electrons, it's going to be with my valence electrons. So it can become 8. So I still have my 16 protons, but now I've got this, I've got this, and this was where my 6 was. I'm going to do it with a different color. So the dotted one is going to be my original position, but if I add 2 electrons, it's going to have to expand a little bit to accommodate those extra electrons. So now it's going to be this. Now if we remember our atomic structure, again, we're going to deal with the S neutral right now. I'm going to draw a line here. Draw a line here. If I do my S neutral, it's going to be, I'm not going to change the neutrons much because, again, we're not really worried about those. So I got 16 protons, neutral charge, 16 neutrons because 32 minus 16 is 16, and then my electrons are going to be 16 because that's a neutral atom. What's my change here? Well, I've got S with a -2. I still got protons with 16, never changes. Neutrons, 0. Charge, 16. And now my electrons are 18. So which way is my Coulombic force or my nuclear force going to be going? So the one that's the highest value as far as the charge, which is 18. So it's going to be, instead of inner, it's going to be outer. And it's going to go out this way from my force. So basically what I just call that is a nuclear or a nuclear imbalance toward the electrons. And if my balance is toward the negatives, it's going to go out toward the negatives. Let's go ahead and go a positive. This one's kind of a little easier to see. So let's go with the same set. I did the going to argon. Let's go calcium. So again, we're going to do our coulombic force and everything with calcium. Well, calcium has 20 protons, and in this case now 20 electrons. Now it's going to do its normal thing. It's going to be a big fat lazy loser in this case. And you're going to kind of start predicting what's going to happen here. So I got 2 electrons, I've got 8 electrons, and I've got, we'll do the normal one, 8 electrons here and 2 electrons here. Usually it just goes 8, 8, 8 because it's, again, higher energy levels. Okay, so we got this, we got this. We want to get to this from this. We're going to lose 2 electrons because that's what positives do. Well, if I lose 2 electrons, what's going to happen? Well, this is my neutral charged calcium.
Good morning,
So we're going to go.
Scholars, if you're located on the second floor, please transition to your second period class. If you're located on the second floor, please transition to your second period class.
What's going to happen with this one? Well, I'm going to have 20 positive protons. I'm still going to have the same assembly here. But I lost 2 electrons. What 2 electrons did I lose? This. So what happens with this one? Well, if I don't have those 2 electrons there anymore, it's going to become like this. It's actually going to be smaller than just keeping it here, but again, that's just your imbalance. So you got this. I'm going to do the same thing here versus that. And we have 20 protons, mass of 40, so it's going to be 40 minus 20, which is 20, and then my electrons, well, it's going to be 20. Let's go with my protons here. Well, I got 20 protons, 20 positive protons, 20 neutral neutrons, and I lost my 2 electrons here, so now I have 18. Again, we're talking about our imbalance in the coulombic force or the nuclear force. Where is all my force going to be coming from now? It's going to be coming from here now, which means I have less protons, which means I have more attraction here. And now it's going to go to the nucleus. Now it's based on numbers. So if I have a positive 1 charge, then it's not going to be moving toward the nucleus as much, especially if I have something like this. It cannot have a positive 1 charge. Now let's compare charges that maybe are both positive, but they're right next to each other. And that's where things get a little bit different. And you can actually look at it number-wise. So let's go, the best one for the negatives would be actually phosphorus and sulfur. So we're going to just repeat this one, and now we're going to change this one. And I'm just going to show it with numbers. This one's going to gain 2. This one's going to gain 3. You can think of it kind of like gaining weight. 1 pound, 2 pounds, 3 pounds. You gain more weight as you go to 3 pounds. So again, this one's going to gain 2. So what are we going to have for my structure? My protons are going to be 16. My neutrons are still going to be 16. 32 minus 16. Not doing isotopes. Again, it doesn't really matter as far as your attraction anyway. And then I have electrons. If I'm gaining 2, how many electrons am I going to have? Well, I'm gaining 2 off of this one, so it's 18. Let's go ahead and do the other one. My neutrons are actually going to equal 16. 15. And now I'm going to gain 3. So believe it or not, these are still isolated.
Good morning, educators and scholars. Scholars, if you're located on the first floor, please transition to your second period class. Scholars located on the first floor, please transition to your second period class. Thank you.
So if you're picturing this, you're going to have, this is my 18th electron for phosphorus. Then you're going to have this. Which one has more of the imbalance? It's going to be here. This one's going to be larger than this one. So this one's going to be smaller. This is because I have 3 more electrons here, and I have 2 more electrons here. Again, ionic is a lot different than atomic radius. So you got to make sure, usually the indicator is going to be your charge. It'll indicate it's going to be running a little bit different. Now let's go with the positives. And we're also going to go with the isoelectronic part. Again, it's kind of easier to do, let's do Al and Mg. Let's do Al and Na and see what the difference here is. Now we're dealing with positives. And we have, for this one, let's see, Al. And at the end, I'll tell you the moral to the story. So let's say we have Na, that's protons 11. Hmm. 11 protons. So this would be 23 minus 11 for my structure, 12. Again, I'm not really too worried about that because we're dealing with charges, not mass. And then we have electrons. Metals are losers, so this is a loser. It'll lose 1 off of my 11, so that's going to be 10. Now let's go ahead with the aluminum. Well, my protons are now going to be 13. Neutrons are now, well, it's going to be 27 minus your protons, 13, which equals 14. And then my electrons one's going to be losing 3. It's a loser. So again, it's going to be something called isoelectronic. Same number of electrons. That's all they're trying to do. They're just trying to become a noble gas. Now again, we're looking at the Coulombic force. And you're going to notice that now my atoms are going to change with this. So we're going to do the Na first. So I've got 11 protons, in this case here, and now I have 8 electrons. So my imbalance is now toward the nucleus. So now this is going to get smaller than the neutral atom because it has less electrons now. Now let's go ahead with the aluminum with +3. Now I've got Al with, let me put that, 13 protons. Isoelectronic still. Now I have more attraction here because this is where my force is going. Again, I call it nuclear imbalances. This one lost 1. This one lost 3. So with this one, which one has the greatest ionic radius? It's going to be this one here. Which one has the least ionic radius? It's going to be this one here. So again, the trend's a little bit different. Positives kind of keep their pattern toward the regular. It's just the nonmetals don't. You might have noticed, maybe you haven't, that things are a little bit different as far as the charges and the radius. And you notice there was a difference in the charge numbers. So here's what I would say. Let's say I'm dealing with ones in the same period. So I have a K plus 1, a Ca plus 2, and a gallium plus 3. If you look at it in relation to your charges, the higher the charge on your metals, the lower the ionic radius. Again, moral of the story, but I had to show you the process. Let's say I'm looking at Cl and S and P. Well, which one's going to have now the higher ionic radius? So you remember at the beginning I said positives are just losers. So the more you lose, the lower it's going to get. These ones are my gainers. The more you gain, the higher you get. Hopefully that clears up anything on ionic radius.